Modernising the power sector and greater electrification will require smarter grids. Smart grids can help save electricity and CO2 emissions directly through better management of the grid, but also indirectly through enabling a greater share of variable renewables and facilitating the deployment of plug-in hybrid and all-electric vehicles. Our analysis shows that the global deployment of such smart grids could deliver CO2 savings between 1 and 2 gigatons by 2050, which is equivalent to 4 to 10% of 2050 CO2 emissions from power generation in our baseline scenario. I now turn to look at the technology changes that we will need in the end-use sectors, starting with transport. Now, transport today accounts for around about 30% of total CO2 emissions, including the upstream emissions from refining oil products. In our baseline scenario, most vehicle technologies will continue to use oil products like gasoline and diesel. For instance, in the case of light-duty vehicles, so that's automobiles and SUVs, oil products account for 92% of total fuel use in 2050, which is only very slightly lower than the 98% now. However, in the blue map scenario, we see the introduction of a wide range of new technologies, including hybrids, plug-in hybrid electric vehicles, all-electric vehicles, and fuel cell vehicles. And we also see new fuels, such as biofuels and hydrogen, taking a substantial share. As a result, oil products represent only 50% of transport fuel use in 2050, and the stock of electric vehicles and plug-in hybrids will reach over 1 billion globally. We will also need to see dramatic changes in the industry sector. Currently, industry is the largest source of CO2 emissions today, accounting for about 40% of total energy-related CO2 emissions, if one includes the indirect emissions from electricity. And a decarbonised power sector will help to reduce overall industry emissions, but action is also needed in all the intensive sectors to reduce direct emissions. And under the blue map scenario, we see direct emissions falling by 24% in 2050 compared to 2007 levels. Energy efficiency and CCS will be the two key abatement options. Many of the energy efficiency options that we will need are available today, and so the immediate priority should be to deploy the best available technology across all sectors. But we also need urgent action to demonstrate CCS in heavy industry so that it can be commercialised in the next 10 to 15 years. Cement and iron and steel are the two sectors where CCS is likely to be most needed. Again, in the building sector, which currently represents around about 30% of energy-related CO2 emissions, if one also includes the indirect emissions from electricity, efforts to decarbonise the electricity sector will be key to achieving significant reductions in the sector. This figure shows that almost half of all emissions reductions in the building sector in the blue map scenario come from decarbonising power. Another 20% of the emission reductions will come from more efficient cooking, lighting and appliances, and roughly the same amount from the more efficient use of space and water heating and cooling. The remainder will come from improvements in the building envelope. So key technologies to achieve this change in the sector include solar heating and cooling, heat pumps and combined heat and power. And also when one looks at the building sector, you can see differences between OECD countries, that's developed countries, and developing countries. In developed countries, most of the building stock that we have today will still be existing in 2050, and so the challenge is to decarbonise the existing building stock. In non-OECD countries, we will see a rapid growth in new buildings, so it's important that those buildings should be built to the highest standards. To achieve the energy revolution that we see in the blue map scenario, all major economies must play a role. As this chart shows, energy demand in OECD, that's developed countries, will remain relatively flat, while in non-OECD or developing countries it's expected to double between 2007 and 2050. If this happens, then we will not be able to meet our climate or energy security goals. Countries need to work together to ensure that the rapidly growing economies outside the OECD do not follow the dirty development path that OECD countries have done to date. Accelerating the spread of low-carbon technologies to non-OECD countries is therefore a critical challenge. As we can see from this figure, 2/3 of the CO2 emission reductions in the blue map scenario in 2050 come from outside the OECD. This will clearly require the global spread and deployment of low-carbon energy technologies. And we believe that a low-carbon economy should ultimately be based on market principles, and we therefore need to work towards reorienting existing trade to a low-carbon path, while also build capacity in developing countries. And while developed countries have historically been leaders in low-carbon technologies, technology transfer is becoming more complex, with increasing multi-directional flows between and among OECD countries and non-OECD countries. And we see the capability for developing and manufacturing low-carbon technologies improving rapidly in many emerging economies, led by China. And the pattern of investment needed under the Blue Map scenario reflects the fact that all countries will need to deploy low-carbon technologies. Although developed countries will require the largest additional investments from 2010 to 2030, investments in other major economies, countries like China and Brazil and South Africa, is only slightly lower up to 2030 and will surpass that of OECD countries afterwards. And these numbers show where the investments are needed based on the least cost abatement path. They say nothing about who might actually pay for these investments, the so-called issue of burden sharing.